Thank you everyone for attending this talk. I know there's like lots of good topics across different halls, and I appreciate you guys coming to see and watch this talk. Before I start, just show of hands, who here is working with data? Like you're in an analytics team or data engineering team? Okay, great, cool. So yeah, just a brief introduction, like similar to what our host provided. My background is in pure mathematics. That's what I studied in undergrad. And I love to do home labs. So like I like to cosplay as a sysadmin at home. So I self-host a bunch of things like my router, a network-wide ad block. And just earlier, I mean the previous talk before this talks about issues during conferences about laptops dying. And since I love old technology, my laptop does not have an HDMI. It's using VGA, and suddenly it died on me. So it's pretty funny. Yeah, so I like to listen to and lift heavy metal, and I'm Kushi's dad. It's my son right here in our trip to Japan just last year. Yeah, so what makes the casino industry unique? Next slide, please. So basically, we're just like everybody else. So everyone who've worked with data, you'll see this architecture to be fairly similar to what you guys have. Like you have a bunch of your data sources, and somehow it gets dumped into your company's data lake, and your analyst, your data scientist access that data through some sort of SQL-like language. So yeah, we're pretty much the same as everybody else, but there's one thing that makes our industry unique. So our whole business model is built on probability theory. So if we remember during our probability course in undergrad, actually gambling is it's what it's what caused the study of probability theory is because of games of chance. And in fact, our main KPI is literally called theoretical win. So like other companies, you would measure sales, which is something that you can measure on a tangible way. But our main KPI is theoretical win. It's based on a concept in probability, which we will talk more about later. Another good thing is like your executives understand variability. So in other industries, if let's say your sale is down by 1,000% on this day, they would go nuts. But in a casino, they understand that a lot of factors in play. There could be a jackpot that was hit. There could be a big player, and they understand variance. They literally understand the concept of variance in statistics. And you know your data is normal. So everyone who've done some ML or even linear regression, we have a bunch of assumptions that your data needs to be normal. But in casino, since you know the data generating process, the probability distributions that create your data, you theoretically know them. So the data assumption, the normality assumption in your data, you know it's true. Yeah, so I want to talk more about theoretical win. Let's start with a simple example about credit card roulette. So anyone that has like seen in social media, like a group of friends, usually they put in their cards, and like whoever's cards is picked, they get to pay the bill. So yeah, just remember that game. And suppose, next slide please. Suppose there's three players that play this game, Ben, Chrissy, and Nathan. So Ben, being a gentleman, he offered to put in his card for Chrissy's sake. So essentially, there's three cards in the pool. Two cards is from Ben, and the one card is from Nathan. When they performed the draw, Nathan's card was picked, so he ended up paying the bill. Chrissy thanked Nathan, and Ben is very upset. Because we know in statistics, if we do this activity many, many times, Ben will end up paying more than Nathan. So if we remember in probability the concept of expected value, we can calculate the expected value of this situation. Next slide, please. So we can calculate the expected value of the random variable if we assume that the random variable is like we can assume that the first event is like Ben pays 0, so that's the actual thing that happened. Nathan pays the bill, or Ben pays 9,000 peso because he covered the whole bill. we can calculate the expected value by 0, because that's the event that Nathan will pay, times what's the probability of Nathan's card getting picked, which is 1 in 3. And we have Ben's chance in paying the whole bill, which is 2 in 3, because he has 2 cards in the pot of cards. If we work out the math, it will be equal to 6,000. So it's just like paying for for Chris's bill. It's just that you add randomness factor. That's why if everybody put in their card, if you do it many times, the expected value of that should be 0. So like technically, not 0, but the expected value is just your actual share of the bill. So you will just have to pay for your own food. So now we can apply it to an actual casino game. Everybody knows what roulette is. Yeah, okay. So roulette is like, just a quick intro, roulette is like, you have, for American roulette, you have 2 extra green marks, like one is single 0, and then another double 0. So how do I explain? There's like a pie wherein 18 is red, and the other 18 is black, and you have 2 extra green ones. So if you're American roulette, there's 2 extra green portion, but if you're playing European roulette, there's just 1 extra portion. And if we do the same math as we saw earlier in the credit card roulette example, it will work out that the expected value is 5.26%. We took the negative because the house edge is in terms of the casino. It's in the perspective of the casino. So 5.26% means if you wager 100 peso every hand, the casino is expected to win 5 peso and 26 cents of your wager. So in the long run, if you play many times. With the European roulette, the house edge is just 2.7%. So if you wager 100 peso many times, the casino gets to keep 2.7 peso out of that 100 wager. So everybody has heard of the term the house always wins. So the house always wins not because we're cheating, we're rigging the game. The games are mathematically designed for the casinos to win. So yeah, next slide. So how Python is useful, if we can just do math, right? Like, as you've seen earlier, house edge, anyone who has taken a course in probability, you could derive what a house edge is. But the reality is a bit more complex than that. So say for example, next slide. So say for example, we wanted to give back 10% of a customer's loss every day. So for example, let's say I have 1,000,000 peso and I played for 1 day, and let's say for example I lost all of that 1,000,000 peso. The casino would like to give back 10% of my loss as a rebate. Is that clear? Yeah. Okay. So suppose that's the promotion that the casino wanted to offer to its customers to to attract players. So can we do the same expected value calculation from earlier? Anyone who want to try to guess? Okay, next. So if we actually apply the same expected value calculation earlier, that's actually not right. Because, for example, if we focus on European roulette, there is 18 in 37 chance that the player will lose his 100 peso bet. There is a 19 in 37 chance that the casino will get to keep 90 peso. 100 peso of his wager, but we're giving 10% back. So we get to keep 90 peso only. If you work out the math, it will actually result in a negative number. So the casino will lose in the long run. So that's where the complexity of the problem is. Like, because as casinos, like everybody offers the same. Like I work for Okada, but Solaire offers the same. City of Dreams offer the same. So the challenge as data professionals is like, how do you come up with great promotions to attract players? So how do we solve this with Python? Of course, we can simulate. Sorry, my laptop died, so I cannot show you the simulation code, but let's do it on the first case. So in the first case, we assume a dumb player, like he's betting 100 peso every hand. Like we simulated that he keeps coming back to the casino for 10,000 days, and each day he gets to he plays 100 hands, and out of those 100 hands, he wager 100 peso each time. So if we do the simulation, we can actually calculate on average the casino. So this is in casino's perspective. The casino will win 263 peso out of his out of his 10,000 total wager per day. And that's just applying the expected value formula earlier. So if we, since this is European roulette, 2.6% times 10,000, sorry, is that 10,000? Yeah, you will get this number. So next slide, please. Then if we apply the 10% rebate, so as you can imagine, if you write the pseudocode for this, you iterate, you simulate one day, and each day you simulate each hand, you calculate the total win per day. If the play, because the rebate only applies if the player lost for the day, because it's possible that they win. So if they win, obviously you don't rebate, but if they lose, you rebate. So if we apply this on the dumb bet, like a person keeps betting 100 peso each hand, you can see that on average, the casino will still keep 213 peso out of his 10,000 total wager per day. So not bad, right? But in reality, people is not going to bet 100 peso each hand. So they will, what do you call this? Like when they wager, there's going to be some probability distributions over it. And next slide. And a good assumption on what a good probability distribution is a gamma distribution. Like on the lower end, like there is more value on the lower end than on the higher end. There should be a better distribution than this because I actually have to clip the gamma distribution to fit the minimum and maximum bet. So if you can see here, the person gets to, on average, if the bets follows a gamma distribution, they get to bet about 20,000 peso each day, and the casino get to keep 382 peso. So at the end of the day, our job, what we care about is we make sure that the promotions that we offer to our patrons does not bankrupt the casino. So that's why we run a bunch of simulations for any ideas that there is. Next. But again, as I mentioned, the reality is more complex because there are high rollers, right? There are people who will bet 1 million each hand, 10 million each hand. So of course that has some impact in your simulation that you need to take into account. Yeah, and it should probably a great idea if you want to set up a max rebate amount. So probably you should only rebate at maximum, let's say 1 million peso per player per day. Because again, as you can we go back to one slide? As we can see, the casino we're not always winning, right? The value when it's negative, that means the player wins. Because negative casino win means the player wins. So there's still randomness to it. So that's why we have to probably consider max rebate amount. And the other thing is like, you need to also consider reinvestments. So like, for example, those high rollers, actually not only high rollers, at least in our casino, if you play okay, we can give you free hotel room. We can give you like F&B, like we can give you food. If for really, really high rollers, we can send a limousine to pick you up. We can book business class because I mean the high rollers typically they are not residing in the Philippines, so we can send you like private jets, for example, for really, really, really good customers. So yeah, but again, I'm not trying to sell gaming. Again, please game responsibly, but we cannot deny the math behind gaming is really fascinating. Because another thing I forgot to mention here is if you've heard about the martingale betting strategy. So if you want to go home and try to simulate, like, what if you assume your player is doing a martingale? Martingale betting strategy is like you wager, and then if you lose, you will double your bet. If you lose, you will double your bet again. But theoretically, casino games has a max bet. So your martingale betting strategy could only go up to the max bet. But that's a fun project to try to simulate. And yeah, if you find this talk interesting, if you find the gaming industry interesting, you can reach out to me because we're hiring and we're trying to grow our team. Yeah. Thank you.
Open naman po for Q&A.
Yeah.
Thank you so much for that very fascinating talk, Sir Ben. Now we have some time to entertain some questions on the talk. You may raise your hand so we can recognize you and hand you the mic. So if you have any questions, yes, at the back. You can come up front the mic.
Yeah, nice to talk to you again. Thank
Yeah.
you for this presentation. So I'm assuming like giving a rebate is kind of like a trade-off between like shrinking your profit margins
Yeah.
in exchange for higher overall volume.
Yeah.
So I was wondering, like, hypothetically, if you didn't give a rebate, like, do you guys do like some sort of calculation of like how much like the rebate value will? Oh, sorry. Oh, for photo op? Or- Oh, okay, okay, yeah. So like, what was I saying? Oh yeah, so like, do you guys do like a calculation or like a prediction of like how much the ROI of like giving a rebate will be? Because that costs the casino money.
Yeah, yeah. Okay. Yeah, thank you. That is a very good question. So yeah, of course, before aside from calculating the impact of rebate to the revenue, we need to forecast. We need to forecast how much this gives us, and how do we do that? It's because we know our players. So for example, if you're a casino player, I have historical data about you. I know how much you typically spend. I have a distribution of how much you spend each day. So given that distribution, I can use that as a reference point of, oh hey, how much is this guy going to spend? So yeah, we can still make sure that we're breaking even, and that's where the other reinvestments come into play, like the hotel room, etc. It's part of the things when we do run the pro forma. Yeah.
Thank you.
Thank you. Hey,
Hi, I'm Lester. Given that the industry is within the non-moral, non-ethical industry side of the commercialism, my question is, in doing or creating your models, I mean, I assume you're using more
Yeah.
of the financial,
Yeah.
or even the profitability data points, but have you considered behavioral and the moral side of if, say, for example, if you see that a customer is losing on a streak, are you considering injecting some reality that, or some ethical or behavioral that applies to say that, okay, probably you have to stop this guy, or
Yeah. Okay. Okay. Thank you. That is a very good question, and I will answer it as honestly as I can. Actually, if we see someone that keeps on losing, my job as the data science team is like, we will shoot him some offer. We want you to keep playing. So, to be honest, like, because we are a business, right? But to answer the moral side of things, PagCore, they do have a lot of programs to help troubled gamers. Like, for example, you could submit to PagCore, like, let's say if you have a family member who is a problem gamer, you could contact PagCore and they will be injected into a database of banned players, and they cannot play anymore. So yeah, unfortunately, I am in the revenue generating team. I am not in the, yeah. It's just honestly, actually, you keep losing. I will think this guy he wanted, because based on my experience, the patterns in the data is like, people who keep losing, they're trying to chase their losses. So, for example, if I see someone who lost maybe 10 bets in a row, I'll give you 10%. Oh, so you can keep playing. Maybe on your next hand, you can win. So, yeah. Yeah, that's it.
So I noticed that on some days the minimum bet for some games is 500, and then there are some days where it's 1,000. So I used to think it's because of the season, like bear months it's higher, but then I went once bear months and it was still 500. So can you explain the math behind that, setting the
Yeah,
minimum
good.
bet?
Okay, that's another good question. Actually, our team is very big. We have dedicated team. It's called Product Analytics. Their concern is more about what you just asked. How much should I price this table? Because there is trade-offs with the price of the table. Let's say if I price the minimum bet, if I price it 500, most likely it will attract cheap customers. I have many cheap customer. If I have many players, the dealers get to play the game a bit slower, right? But if you have an expensive table, you probably just have one or two people playing on that table. The game is faster, so that's the trade-off. But they do use a lot of other methods to optimize pricing because that's number one. One consideration is the trade-off between volume and revenue. The second trade-off is the availability of staff. If it's slot machines, no problem. But for table games, it needs a physical person on the floor dealing the games. And another point to add is actually, while the casino is accurate on many points, actually, if you're very good in AI, table games is one key factor where our data is inaccurate because we cannot measure yet exactly how much each person wager. I mean, technically, I can measure how much the people sitting in seat number one bets, but I cannot attribute it to his alone because some people they could be standing and adding extra wager. So yeah, though those factors is also into play when we calculate table pricing, but it's not my expertise. I'm more into marketing. Yeah.
Good afternoon. I'm Kevin from Ateneo United. I have a question regarding how do you combat, like, for example, your players are maybe applying some AI models to defeat your
Question.
system.
Okay, that's another good question. That's mostly for online gaming, but I mean my experience is mostly on the land-based casino. So let's say, for example, blackjack, because it's one of the few games where you can't actually try to beat the house. If you've seen the movie 21, there are card counters. So yeah, usually how we like technically card counting is not illegal, but usually as we've seen, I have a distribution of wins, right? So I know typically, assuming this is the house edge, typically persons should only win within this range. If I see someone who's winning probably a little bit too much, usually what we just do is we just ban them. Okay, you cannot enter anymore. Yeah. Okay.
Actually, in relation to that, one of my thesis advisors are actually developing a new model where we're actually trying to beat basically those imperfect information games such as poker and other like probably games like that. So currently we're training the model, and I think currently it's learning. So I think we have a paper poster presented in the
We can chat later.
I'm wondering, like you mentioned, I think Blackshot is also probably an imperfect information game where the cards are not shown. So just to give an example. So if there's like a possibility that, like you mentioned, this is currently unsolvable, but there's a possibility to be solved. So how do you approach those type of learning models? Do you, for example, hire them or something, or maybe use their model to actually learn the or your content?
If I understand you correctly, like try to use the models that guys like you build and then use that to protect ourselves. Yeah. Yeah, it makes sense, but the thing is like the problems you guys try to solve, like for example, poker. Actually, poker is an interesting game. I cannot play it because I have a jail license. I cannot play into a casino. But those games, actually, it's fun, but it doesn't make the casino much. Because when you're playing poker, you're playing against other people, right? You're not playing against us. So I don't care if you beat him like with 10 million peso. We make money through rake. Like if the pot is 100,000 peso, we take 5% of that, for example. So it has its applications, of course, but I don't see it as something that, because the games we play, for example, roulette, I don't know how AI can be useful to beat roulette.
So
Yeah.
we're trying to see not just the poker but other games.
Yeah, if you can, then talk to me and we might purchase your product. Yeah.
Thank you.
Yeah. She has. Okay.
So I have a question. How does the casino handle like relatively low probability situations, but I think dangerous to the casino, like um, someone who bets a very low amount but consistently wins, let's say, I don't know, 20 or 30 times in a row, or a player who just played one time, placed a very high bet and then won, then never played again. How does the casino make a model for that kind of situation?
Yeah. Actually, the answer to that is like the same as what we saw earlier. We have a distribution. So whether you wager X amount or small amount, as long as the function of your wager and your win is within that distribution, we have no problem. And it's possible to be on a streak, right? Like, because as we see on the distribution earlier, there is like on the left end, on the high end of the distribution, like the casino can win very much, the player can also win very much. It's not a problem again as long as it's within the distribution of the data.
I guess
Yeah.
I guess to clarify that, does that mean that outliers are already handled by the model, or is it?
Yeah.
Does it require another model?
So the thing is like we don't call it outlier because we know it's possible from the data. That's the thing I mentioned earlier. The nice thing about the casino is you know the data generating process. If someone wins this, right, we will not be bothered because we know okay, it's still within the distribution. It will only be a problem if you won somewhere around here that then something might be fishy going on. So that's the beauty of knowing the data generating process. Yeah. I think she has a question. Sorry, she's been raising her hand since earlier. Okay. He pala, sorry.
So actually, a very similar question here is, our probability model heavily relies on a sheer number of volume to eventually normalize our data and turn a profit, right? But what if we go into a situation where volume is too low? How would you adjust your probability model to adjust for the higher variance?
Yeah. Yeah. Okay. Also, that's a very good question. I guess the application of that is the VIP players, because in VIP players, unfortunately, we cannot collect as much data as our VIP players. Our VIP players is probably the top 1%. So, to be honest, this is what happens in the industry. For VIP players, we just sort of don't care. For VIP players, we are also taking a gamble on them. But at least we know probability wise, over the long run, the casinos still tend to win. That's why in VIP players, we are very careful about reinvestments. Because a wrong recommendation on what offer to give a VIP customer can bankrupt. I mean, not bankrupt, but can lose you a lot of money because they are usually playing either this or this because of the huge variance they create. Yeah, thank you.